Hello guys, I'm back. So today what we're gonna do is study the indifference curves, actually the equimarginal principle in Appendix 5. Okay, so it's at the end of the chapter. You move after the summary, after the exercises, you're gonna find the Appendix 5, and it's the easiest way to explain, well, for me, to explain the equimarginal principle. Okay, so the equimarginal principle actually tries to maximize your utility. Remember, utility is the degree of satisfaction you get out of consuming a good. Okay? Now, the first thing we're going to study is the indifference curve. What is an indifference curve? To do that, I'm going to use an example, my example. Okay? So I have a choice between two goods. That would be strawberry flan or strawberry yogurts. Okay? I'm not making any ads for them. That's all I found at home to explain this to you. Okay. For me personally, I am indifferent between having 3 flan, 3 of them, and 2 yogurts, or I'm indifferent. For me, it doesn't make any difference having 3 of these and 2 of these, or 2 of these and 4 of these. For me, it doesn't make any difference. For me, it's equivalent. The satisfaction I get from consuming these or consuming this, the total satisfaction I get is exactly the same. So I am indifferent. Okay? So of course, when I add yogurts, I decrease flan. Okay? This way I keep the same satisfaction, because if I consume more of both of them at the same time, now I don't have the same satisfaction anymore. My satisfaction is a lot bigger. So I'm just keeping the combination here where my satisfaction is exactly the same, the total satisfaction. Okay? So if I have many combinations like this, I can plot an indifference curve. So I gave you the example with yogurt and flan. Now I'm going to move to the example given in the book. In the book, they gave the 2 goods are food and clothing, okay? So for this person that we're studying, having 1 unit of food and 6 units of clothing is exactly as satisfying as having 2 units of food and 3 units of clothing. It's the same satisfaction. Same satisfaction as combination C, where that person has 3 units of food and 2 units of clothing. And then combination D, 4 units of food and 1.5 units of clothing, whatever that means, like a pair of shorts and 1 shoe. It doesn't mean anything, but that's what they wrote in the book. Okay, so this is my indifference combinations, and I'm plotting it as an indifference curve. This is what we call an indifference curve. That means on this curve, you have constant total utility, okay? Total satisfaction. It's the same on each and every point on the curve. That's an indifference curve. Okay, now if I consume, I add here units and here units too. It means you're consuming more of both goods. You're gonna have a higher satisfaction. And maybe we're gonna look at combinations where that satisfaction is constant. It's gonna give you another indifference curve that is higher. Here again, it's constant total utility, but the utility in this one is smaller than the utility of this one, because the more you consume, the higher your satisfaction, okay? So if I do that and I keep going, I'm gonna end up with what we call an indifference map. Of course, this depends on each person. So I have many utility curves. Of course, the one I want to reach personally is the highest one that you can't even see, the infinity one, okay? But we have some constraints. So right now, just remember that the indifference curves are those curves that are downward sloping, because if you add more of both goods, it's going to be another utility curve, indifference curve, okay? So utility of 1 is less than utility of 2, is less than utility of 3, less than utility of 4, etc. The utility of 7 in this graph is the highest one I have. So that's where I would like to be if I limit my graph to 7. Okay? Now, unfortunately, having goods, to consume goods, you need to buy them, and you have an income that is limited. Okay? So, you need to achieve the highest satisfaction you can with the money you have. Okay? So you need that indifference curve with the budget line to intersect. But more before that, I need to tell you what a budget line is. Okay, so that's my constraint. Imagine I have $6 in my pocket. Okay, I hope you see. I have $6. The price in the market for food is $1.5. Yeah? The price of clothing is $1. So, if I buy 0 food, the maximum clothing I can have is 6 units. So, no food, clothing, I have $6, so I can buy 6 pieces of clothing. That would be my maximum in clothing. Okay? It's like the PPF, same reasoning. Okay, now here, if I buy 0 clothing, I have the price of food that is 1.5. So $6 that I have divided by 1.5 for each unit, I could buy 4 units of food. That's the maximum, okay? And then it's a straight line, so you have all the possibilities in between in here. So with $6, that line shows you the maximum you can spend, $6. Inside the curve, it's possible, but you're not spending the whole $6. Outside, it's impossible because you don't have more money. You only have $6, okay? So now what I'm gonna do, I'm gonna put my indifference map with my budget line constraints, because I have the constraint of money, and I'm gonna see what is the highest utility I can achieve, okay? So that's why I have this paper here. That's the graph that I've already prepared. So put this one here. Don't get scared because the graph has all this inside. Okay. Put these here. Oops. Bye-bye. Hopefully I have more. Put this one here. Let me just check if you can see everything. Yes, the handwriting is a bit hard to read, but I'm gonna read it to you. Okay, guys. Or what can I do in order to make it better for you? Let me increase the size only for the graph. Here we go, and then go back and decrease the size. Now you can read everything. Okay, guys. So what I did, do you see it in red? It's my budget line. Do you see it? It's this one here. I have 4 units of food, that's the maximum if I have no clothing, and 6 units of clothing if I have no food, and all the combinations in between are the ones where I spend $6. So the maximum is the red line. Do you see it? That's your max, that's your limit. Anything inside is possible, but you're not spending the whole $6, okay? For example, 1-1 is going to cost me $1.5 for food and $1 for clothing. That would be $2.5. At this combination here, it costs me $2.5. So I'm not spending the $6. Let's look here. I'm gonna go to a combination where it's easier. This one here, not easy. Come on, be nice. 2.5, 1.5 and 4. Okay, 1.5 and 4. 1.5 times 1.5. How much is that? 1.5 times 1.5. I didn't do it. Okay. 15 times 15, that would be 25. That would be 75, 75, 75. That would be 5. Too hard. The combination is too hard to calculate. I'm not going to do it. Anyway, I think you got the point. Here, it's going to be $6 exactly. It's not even 1.5. Okay? On the line, it's $6. I'm not going to redo the video just for this little mess up. Anyway, so you got the point. On the line, it's $6. Inside the line, it's less than $6. What about outside the line? Outside the line, you don't have enough money. Okay? It's more than $6, so you cannot, it's impossible, you cannot reach it. It's that utility that you cannot have. Okay, so now let's see where I'm maximizing my utility. Okay, I bought some pens only for the paper and I'm not using them. That's not very good. Let's use the red one. Okay, here it is. Now guys, can I be at a point here? I wrote next to it impossible, so I cannot. I don't have enough money. Here, I don't have enough money. Here, I don't have enough money. Okay, point D is impossible for me. I put the names here, the combination names. Point A is impossible for me. Let's see here. I put here NX. NX, is it possible? I'm on the line, that means I'm spending the whole $6 I have. Is it possible? Yes, it is. Am I spending all my money? Yes, I'm spending all my money. But I am having total utility 1. I could achieve the same utility by being inside and spending less money. That doesn't make sense. So why would I be here? I could, by spending $6, be in here. NOA. No A. That means point A, but no. Can I be here? It's higher utility. It's utility 2. Yes, I can. I'm spending all the dollars I have, and I'm achieving better utility. But is it the maximum? No. The maximum here is the point B, where you have the line is tangent to the curve. They're not really intersecting, they're touching only at one point, and that's point B. At point B, you have the highest utility you can achieve with the money you have, which is $6. Okay? You can be on another utility curve because it's within the impossible zone. So the only place you can be with the highest utility is utility 3 with point B. Okay, so what's so interesting about this point is that mathematically, the slope of the curve and the slope of the line at this point, exactly the point of tangency, the two slopes are equal. And that's for what we're looking for. Okay? So, The 2 points are equal, the two slopes are equal at only 1 point, and that's the point of tangency between the highest utility you can achieve with your budget line. So let's move here, and now I need, no, I can still not increase the size of the thing. Okay, at point B, which is your maximum utility, slope of the utility curve is equal to the slope of the budget line. What is the slope of the budget line? It's simply the price of food, it's the price of clothing over the price of food. I mixed it, but it's okay. Because I have clothing here, food here. Here it doesn't really matter because I followed the book and that's what they had, which is not correct. Anyway, it's price of clothing over price of food. Anyway, doesn't matter. It's the reverse should be equal to, so I'm going to keep as they did it in the book. So PF over PC should be equal to the change in food. We can reverse this. The change of food over the change of clothing. Okay, what is the change of food over the change of clothing when it comes to the utility curve? It's simply the marginal utility. The additional, delta means additional change, which is exactly the word in economics for marginal, okay? So you're gonna find that the price of food over the price of clothing is equal to the marginal utility of food over the marginal utility of clothing. I hope you see. Okay, now I'm gonna play with the formula. I'm gonna put MUC over here and PF over here, okay? So it's gonna give me the marginal utility of clothes over the price of clothes is exactly equal to the marginal utility of food over the price of food. That's when you have those two ratios are equal, that's when you have the maximum utility. That's the point where you maximize the utility you're getting out of the consumption, okay, of the two goods. And this is the equimarginal principle, okay? That's the equimarginal principle. Clear, guys? So we achieve the maximum utility when we succeed in equalizing the marginal utility of each good over its price with all other marginal utilities of the goods over their prices, all of them in a basket of goods. Here we have 2 dimensions, so we can only do it with 2 goods. But in reality, you don't buy one good, you buy baskets of goods, many goods. So you're gonna keep buying the highest marginal utility of a price till you try to equalize the marginal utility over the price equal to all the other marginal utilities over the prices. I don't know if you see me or not. Here I am. Okay, did you get the equimarginal principle? I do hope so. So just remember, this is the thingy you're trying to achieve when you buy many goods, okay? You're trying to achieve to maximize your utility. So each dollar that you spend should bring you the equal marginal utility for each dollar you spend. That's what we're looking for. When you reach that, you are actually maximizing utility. Okay? Now, I'm gonna move on. Let me see if I have taken too much time or, yeah, 19 minutes. So I can still continue. Okay, I'm making it smaller. And now I'm taking all this away and we're gonna see the substitute effect. Okay? Now moving to another view of the substitution effect. This one doesn't work anymore. Let's see this one. Yeah, it does work. I'm sorry. So Now I need this one. This was Appendix 5. Now I'm going back to the chapter to see another way to look at the substitution effect, to look at the substitution effect, which is one of the reasons the demand is downward sloping, okay? The substitution effect. Okay, now what is the substitution effect, if you recall? Do you remember? Okay, goods A and B, I'm rewriting it here. You have it. We have done this in chapter 3. Okay, goods A and B are substitutes if, when the price of A increases, what's going to happen to the quantity demanded of B? The quantity demanded of A, the quantity demanded of A would automatically decrease. They are substitute when, because the price of this one increased, you decrease its quantity, you buy the substitute good, quantity demanded of B increases. Okay? Because you have substitutes, I'm gonna put the arrow. Okay, guys, butter and oil. Do you remember my mom's cake? Okay, when the price of butter increases, my mom buys less butter and substitutes it. She buys more oil, okay, to make the cake. It's not that tasty. I don't like it. Anyway, so we substitute a good with another one because the price of one of them increased. Now, let's look at it from the marginal utility point of view. Imagine I have the marginal utility of A over the price of A. Let's make this one butter. Okay, I'm gonna write it actually here. Marginal utility of butter over the price of butter is equal to, let's say, 100 over 10. Okay, so here I have 10 utils per dollar. For each dollar I spend on butter, I have 10 utils. Now I'm gonna move to the marginal utility of cooking oil, of course. Cooking oil over the price of cooking oil. Okay, it's equal. Of course, marginal utility is not constant, it decreases, but for now we're just gonna do it with these two numbers. Okay, cooking oil, let's say 50 over 2. 50 over 2 is gonna give me 25. Now I want it a bit higher, so right now I'm indifferent. 10. Okay, 50 over 5. That gives me 10. Right now I'm maximizing my utility. I can buy this one or this one, same thing for me. I don't know. Okay, I'm here. 10, 10. Let's imagine that the price of butter increased. What's gonna happen? Now it moved to 20. So instead of 10 utils per dollar, I'm gonna have 5 utils per dollar. So each dollar brings me 5 utils, while in oil, it still gives me $10 per util, 10 utils per dollar. So what is my mom gonna do? Buy the one that brings her more satisfaction. Okay? Remember, you keep buying the good with the highest marginal utility over the price till you try to equalize, because you know the marginal utility decreases. You're trying to equalize the marginal utility over of a good over the price of that good with the marginal utility of the other good over the price of the other good. Okay? So here, because the price of butter increased, price of A increased, my mom is going to go and buy cooking oil, so the quantity demanded for B is going to increase. And now you're looking at it not from the real substitution like cooking butter and oil, but for all goods. Can take the marginal utility of books over the price of books, compare it to the marginal utility of chocolate with the price of chocolate. Okay? So whenever you have a basket of goods, you keep buying the highest ratio till, and you're trying to equalize the last dollar spent on each good to be equal. Okay? I'm done with the equimarginal principle, and I'm done with the substitution effect. Now I'm moving. Do I have time or do I have to stop? 26 minutes. I think I'm gonna stop here, or I'm gonna do the paradox of value. Okay, I'm gonna continue a bit. So give me just a second, because I wasn't planning on going so far. So finished with the indifference curves. Now I'm gonna move to indifference curves done. Let me just see. Equimarginal principle. Okay, from demand, from individual to market demands. That's what I'm gonna do. Look at what I bought. This is better, isn't it? The new pens I bought are not as good as the old ones. You see here, I have a little, anyway, I don't care. Let's move from individual to market demands. From individual to market demands. I know you're gonna ask, why are we doing this here? It's because later on we're gonna link the utility to the demand, okay? So from individual to market demand, and here I'm gonna give you an example. Price 5, 4, 3, 2, 1, and I have Mr. A, Mrs. B, Mr. C, and Mrs. D, okay? Or Ms. D. We're gonna be politically correct. Okay, guys. Now, I have the prices, and I'm looking at the good that each one of these buys. So at the highest price, we buy the smallest quantity. So here I'm gonna go, this one doesn't buy anything, 2, 4, 6, and 8. Okay? So when the price is 5, Mr. A buys 0. When the price is 4, Mr. A buys 2, etc. You notice that when the price decreases, the quantity increases, and vice versa. So this is the demand for Mr. A. I'm going to go to the demand for Mr. B, same prices, and I'm going to look at the quantities. So here, 2, 4, 6, 8, 10. Okay? Making it easy on myself. Moving on, Mr. C, same thing. I'm going to go 1, 2, 3, 4, 5. Okay, how much do I have now? And here, Mr. D, I don't know, 3, 4, 5, 6, and 7. Okay. Now each one of these is an individual demand. If I want the market demand, how am I going to get it? Knowing that these are the only 3 people I have in my market. A small market. Okay, what do I have to do? Well, if Mr. A buys 0 at price 5, Mr. B buys 2, Mrs. B buys 2, Mr. C buys 6, Miss D buys 3. All of them, how much do they buy? What's the quantity in the market demanded at 5? It simply would be the sum of all the quantities. Okay? So, quantity demanded for the whole market, which is simply the quantities of each one of them, summed. Sigma, individual quantities demanded. So that's the market. I hope you see it. Okay, I don't have a calculator, so I'm in a pickle right now. Okay, 3 plus 1, that's 4, plus 2, that would be 6. And here is my quantity. Okay, for 5, price 5, quantity demanded is 6. Price 4, 4 and 4, 8, plus 2, 10, 12. Okay? Here it's going to be 4 plus 6, 10, plus 5 and 3, that would be 18. That would be my quantity demanded. Here it's going to be 10, 18, 24. Yeah, the slope is 6 over 1. No, 1 over 6. Minus 1 over 6. 24. And here it's going to be normally 30. Yeah, I guess it's 30. It's plus 6. So here are my quantities demanded at each price for the whole market. So I simply, at each price, I summed up the quantities. Okay, now if I want to plot the market demand, I simply take the prices, 1, 2, 3, 4, and 5, and then the quantities, I'm going to go 6, 12, 18, 24, 30, is it 30? Yeah, 6 times 5. So 5 is 6. That would be my market demand. Well, normally it's going to be a straight line, but I don't have, well, I do have a ruler, but I don't want to waste time with this. Okay, so we did that when the demands are different for each individual. Now, what if I have a table for one person and we are many people having exactly the same table? That would be even easier. Take a screenshot. Now I'm moving to the other part. What if I only have here, I'm going to take 1, 2, 3, 4, 5. It's going to be easier to, oh, okay, 2, 4, 6, 8, and 10. Okay, so that you see it, because with the 0 you're not going to see it. I have Mr. A buys at price 5, 2, at price 4, 4, at price 3, 6, at price 2, 8, and at price 1 buys 10. Okay, we're going to assuming the market is made of 100 Mr. A's. That means I have Mr. A has this demand and I have Mr. B has exactly the same demand schedule. Mr. C has the same schedule. Miss D has the same schedule. They all have the same demand schedule, and there are 100 in the market. So how am I going to find the market demand? So that's my assumption. Market size. So my market demand is the sum of each one of them, okay? Market quantity demanded would be the sum of each one of them, but you're summing the same number 100 times, it becomes a multiplication, okay? So it's simply gonna be the quantity demanded of Mr. A times the 100, which is your market size. You get it? So it's at price 5, each one of us buys 2. So all of us, we are 100, we're gonna buy 200. At price 4, each one of us buys 4. So all of us, we're gonna buy 400. Each one of us buys 6. So all of us are gonna buy 600. Each one of us buys 8. All of us are gonna buy 800. And at last, each one of us buys 10. So all of us, we are 100 people buying exactly the same thing at the same price, the same quantity at the same price. So we're simply multiplying the quantity demanded by the market size, and it's going to give us the quantities demanded by the whole market at each price. You got that? Okay, good. Now, I want to talk about something else, but I'm going to check the time. Okay, no, now I have to stop. I have to stop because it's getting long, and when it's long, it doesn't want to upload. Okay, guys, love you. I hope you got this. We're going to continue next time with chapter 5. I hope you read the whole chapter, and you read the appendix too. Love you. Summarize your chapters because they are due. Don't forget that. Bye, guys.